So welcome to this latest video on 162 Maths, and in this video we'll be going over some GCSE Maths higher revision, looking at some big mark questions taken from some past exam questions. Now a little reminder, if you're new to these series of videos, that a copy of the questions that we're going to go through is available for you to download in the description below, and I strongly recommend you do that just so you can test your prior knowledge. Now, before we get started, there is a copy of the questions that we go through in this video along with the official mark scheme for you to check your answers, and I strongly recommend that you have a go at these questions without watching this video just to see how well you would do on each of these questions. Now, the topics covered in this particular video is going to be a 5-mark question on a question involving coordinate geometry and circle theorem, a 3-mark question on quadratics, a 4-mark question on exact values of trig with a incorporation of trig graphs, a 4-mark question on transformations, another 4-mark questions on circle theorems and fractions and surds. Now, there's no indication about whether these questions are going to be a calculator or a non-calculator, so I strongly recommend try not to use a calculator on these questions, but if there is a need to, then do feel free to use one. It's just if you can prepare to do these questions without a calculator, it just makes your life a lot bit easier. And definitely the exact values of trig is definitely going to be a non-calculator question. So let's get started on question 1. So question 1 reads, 4, 8 is a point on the circle with centre O. The tangent at 4, 8 intersects the x-axis at P, and the question is asking us to work out the x-ordinate of P. So let's just have a look at this particular question. Now, whenever you see a circle and a tangent being mentioned, then it's always important to mark the radius to the tangent at any point that's been given. And the reason for that is because the radius always meets the tangent at 90 degrees. So if I just call this point T, then we know that OTP equals 90 degrees. And the reason for that is because the radius meets the tangent at 90 degrees. It's one of the circle theorems. So therefore, what we know is that OTP, or triangle OTP, is a right angle. Now, in this particular case, that's not really important, but again, if we want to use Pythagoras, we could do to work out any particular length. So for example, we could use Pythagoras to work out the lengths, but again, in this particular question, it's not really needed. But it's always important to actually state what that is. Now, in this particular question, what we need to do first is we need to find the equation of the line TP. Or PT, I should call it. Doesn't really matter, but there you go. Now, to find that, what I need to do is I need to find the gradient and I need to find the coordinate. Now, the coordinate has already been given to me, which is 4, 8. So what I need to do is then go about finding the gradient of that line. Now, the first thing I can spot is I can then work out the gradient of OT. Now, the gradient of OT, if I just hover down here, now using the coordinate of 4, 8, 4 is the horizontal length, so that's going to be 4, and 8 is the vertical length, so that's 8. So then working out the gradient of a triangle, it's the length up divided by the length across, so it's going to be 8 divided by 4. And as you can see, that line which I'm trying to work out of OT is going up, so it's going to be a positive gradient. So that's going to give me a gradient of positive 2. Now from this, what I can then do is then work out the gradient of PT. And that is because the radius and the tangent is perpendicular because it meets at 90 degrees. So therefore, if I do the negative reciprocal of that line, it gives me a gradient of a half. Now that I've got the gradient and I've got a coordinate, the next thing for me then to do is to find the gradient, or the equation, sorry, of the line PT. Now to do this, what we need to do is we can either use one or two methods. So the equation of PT. So I can either use y minus y1 equals mx minus x1, or what I could do is I could use y equals mx plus c. Now I'll go through both just so you can see how we get the answer using each of those methods. So using this method, I know that m equals minus a half, and I've got the coordinate of 4, 8, so x1 is 4, y1 is 8. So substituting those numbers into this formula here, I get y minus 8 equals minus a half x minus 4. Then simplifying, get y minus 8 equals minus a half x plus 2, in which then I get y equals minus a half x plus 10. So there's the equation of the line PT. Now if I was using y equals mx plus c, then again I know that m equals minus a half, x equals 4 and y equals 8. So 8 equals minus a half times 4 plus c. So then 8 equals minus 2 plus c. So c equals 10. So I still get the exact same equation of y equals a half x, oh that is a 2, plus 10. Now using the equation of the line, I could then work out point P. Now at P, the y ordinate is 0 because it's at this point here. So then substituting that in, I get 0 equals a half minus a half x plus 10. Take the 10 over, in which I get minus 10 equals a half x. Take the half over, and I get, or the minus a half over, in which I get positive 20. So x equals 20, and that there is my x ordinate of P. Moving on to question 2, and let me just zoom in because we can, so we can see it clearly on the screen. It says the only solution to x squared plus bx plus c equals 0 is x minus 15. Work out the values of b and c rather. Now if there's only one solution, now what that basically means is we're going to only have one bracket in the quadratic, so I'm going to end up with something that looks like this. Now if the answer is minus 15, then what number goes in the bracket is going to be positive 15. So then all I then need to do is expand this out to get the quadratic equation in this form. So here we've got x plus 15 rather, x plus 15 equals 0, and then expanding the brackets I'm going to get x squared plus 30x plus 225, and then it's just a case of comparing the coefficients, in which I get a b value of 30 and a c value of 225. Moving on to question 3, it says 4 times sine 30 times tan 30 times cos 30 equals sine y. Work out one possible value of y. You must show you're working. Now this is going to be an exact values of trig. Now one thing I always recommend to my students is to actually write down what these values are. Now again, there's several ways in which you can remember it. I've got several videos in which I'll include that in the link in the description on how and what the exact values of trig are. But whichever way you find it, sine 30 is a half, tan 30 is 1 over root 3, or root 3 over 3, depending on whether you rationalise the denominator, depending on how you find it, but it shouldn't make a difference. And cos 30 is root 3 over 2. Now once I've got these values here, all that's left for me to then do is substitute it into the expression. So here I've got 4 times a half times 1 over root 3 multiplied by root 3 over 2, and that equals sine y. So then just simplifying it, if I do these two first, 4 times a half is 2 multiplied, and again a multiplying fraction, so multiply the numerators and the denominators together, and I'm going to get 1 times root 3, which is root 3, and root 3 times 2 is 2 root 3. Now again, taking the 2 over, that's just going to equal 2 root 3 over 2 root 3, which equals 1. So what that then tells me is that sine y equals 1. Now if I then look at the graph of the sine graph, and again I'm just going to look at positive values, and the sine graph looks something like this, and it continues, and it also continues into the negatives as well. And I don't think it says whether y is positive or not, doesn't. So here we could end up with negative values. Now if I then fill in the gap, so this is 90, that's 180, that's 270, that's 360, that's 450, etc. Now where it hits 1 is at this point here, that point way over there, and also that point over there. So here y could easily equal, the nearest one to the origin is going to be 90, the next one is 450, and again you could go in any direction, but the formula to work out whether your answer is correct, but I would say 90 is probably the most popular, 450 less so, but basically y equals 90 plus or minus 360 n, where n can be any number you want. So again, if you've gone out the box and thought outside the box and put a really rogue value, as long as you substitute it's a multiple of 360 plus or minus 90, you're going to be fine to get your answer. But I would say the most common answer that most people write is going to be 90. Moving on to question 4, and I'm going to have to zoom out for this one, so apologies if you're working off the screen. Let's just go back to that question. And it says that triangle ABC is drawn on the grid. And it says that ABC is transformed to A-B-C- by the reflection in the line of x equals 1. A-B-C- is then transformed again to A-B-C- by the rotation of 90 degrees anticlockwise about 1 minus 4. And the question is asking us which one point on ABC is invariant under the combined transformation. You must show your result of each transformation on the grid. So looking at this first one here, we want to perform the transformation of a reflection on the line x equals 1. So first things first, what we need to do is to kind of draw the mirror line of x equals 1, which I'll do there. So that's x equals 1. I'm going to reflect the triangle ABC onto that line, which is going to be 2 away. So it's going to be here. So if I just draw, and again, you should be using a ruler, but it does take a while on the computer, so I'm just going to sketch it here. So this is going to be C dash, that's going to be A dash, and that's going to be B dash. So that's the first transformation done. And let me just colour it in so you can see that that is the one that we've done. Now the next one that we then need to perform is on that yellow triangle is to do a 90-degree rotation anticlockwise about the point 1 minus 4. So the first thing I need to do is first of all plot the point of 1 minus 4, which is here. So there's my center of rotation, and I then need to rotate that along this line. Now I would definitely recommend using tracing paper. Now sometimes in the exam it's usually on your desk, but it is available on request. So if you're using tracing paper, then that's absolutely fine. There are different ways in which you can do this without tracing paper, but again, that's entirely using your skills of rotation. But what you should find is that the triangle under that second transformation should be looking like something that looks like this here. And if I was to label the points, that this point here is going to be A dash dash, and this is going to be C dash dash, and that point there is going to be B dash dash. Now the question is asking which point is invariant. Now invariant is just another word for means that does not move from the original point. And as you can see, B dash dash is on the same as B, so that is the point in question. So the point that is invariant is going to be B, or you could write down the coordinate, which is minus 4, 1. But again, I'd probably go for B in that particular case. Now if a question did ask what's the combined transformation, then I would say it's going to be reflection on the line, and then what you then need to do is draw your mirror line, which is going to look something like that with a straight line. And I would say the equation of that line is going to be y equals minus x, and it crosses the x-axis or the y-axis at minus 3. So if the question did say what's the combined transformation, I would say it's a reflection on the line of y equals x minus 3. But it's a complicated one, but you wouldn't get that, I would say, at this particular level. But if you did, there you go. Moving on to question 5, it says that PQR are points on a circle, SP is a tangent to the circle, and RQ equals PQ. And it says prove that y equals 90 minus x. So if I just slowly zoom in so you can see it on the screen. So what we need to do is look out for this. Now we know the words tangent and we've got a triangle, so we're looking at alternate segment theorem. Now from this, what we know straight away is that this angle here is going to be 2x. And the reason why that's 2x is because of the alternate segment theorem. So from this, what I then know is that triangle RQP is going to be a isosceles triangle. If I can spell it, yes I can. It's an isosceles triangle as RQ equals PQ. So therefore that this angle here is also going to be therefore y. Now from this, what I can then do is I know that 2x plus 2y equals 180. Then dividing everything by 2, I get x plus y equals 90. And then comparing what I want y the subject. So I take the x over, in which I get 90 minus x, and there is what they wanted me to prove. Then moving on to our last question, it says work out root 2 13 over 16 minus 2 over root 5. And it says give your answer in the form of a root 5b, where a and b are integers. So let's have a look at this. So the first thing we want to do is to write this as an improper fraction. So 2 13 over 16 is going to be equal to 2 times 16 plus 13, which gives me an answer of 45 over 16. So then replacing that yellow with the orange, so what we then get is root 45 over 16 minus 2 root 5. Now there are several ways in which to do this answer. So if you get to the final answer and you get the right numbers or the coefficients of a and b, then that's going to be absolutely fine. There's a good chance you've done it right, but your method might be different to mine. Yours might be quicker, mine might be longer, or mine might be quicker and yours might be longer, but as long as we get to the right answer, it's all good. So first things from this, what I can then do is to use one of the laws of surds, which is right, this says root 45 over root 16 minus 2 root 5. Now just on the side note here, root 45 is equal to root 9 times root 5, which is 3 root 5. And root 16 is just 4. So if I substitute that into this line here, then what I end up with is 3 root 5 over 4 minus 2 root 5. Now from here, what I want to do is, as I'm subtracting, I want to have fractions, I want to find a common denominator. So here my common denominator is, so if I just write common denominator equals root 20. So to get root 20, I need to multiply this fraction by root 5, and I need to multiply this fraction by 4. Now doing that, what I'm going to end up with is 3. Now root 5 times root 5 is root 25, which is just 5. So that's just going to be 3 times 5 over 4 root 5 minus, and then that's going to be 8 over, and then it's going to be 4 root 5. Now from this, what I can then do is just simplify them. So I get 15 over 4 root 5. Oh, don't know what's happened there. There we go. Let me just correct that so we're not getting confused. So we get 4 root 5 minus 8 4 root 5, which is going to give me 7 4 root 5. And now then what I then need to do is rationalize the denominator. So if I multiply all of that fraction by root 5 over root 5, I get 7 root 5 over 4. Root 5 times root 5, as we know, is just 5. So that's going to give me 20. And as you can see, that is now in the form of a root 5 divided by b. So here is my final answer, where a equals 7 and b equals 20. And again, all we need to do is just write it in the form. We don't need to write down what a and b are. So my final answer is just going to be 7 root 5 over 20. And there we go.